Welcome to our series of videos that explore various aspects of implementing inquiry science in different science class situations. This episode looks at Year 10 science students from the Growing Tall Poppies program, undertaking a 3-day intensive program at La Trobe University. The aim of using an inquiry science approach in this instance is to show how a 5 E's approach of engage, explore, explain, elaborate and evaluate can be supported through the students conducting an authentic scientific experiment. The experiment being undertaken in this case uses the atomic force microscope, laser diffraction techniques and a regular microscope examination to perform a comparative analysis of human hair.
There are many problems in the real world that affect us on a very tiny scale. And just like through this project, we investigated how we can measure hair using light diffraction and just seeing the surface of hair. We know that this technology can improve our life quality by targeting problems that we cannot physically fix because we are just so huge.
Being involved with the Growing Tall Poppies program has really powerfully influenced how I'm thinking about teaching and going into next year, because I've seen how much students can change, how much engaging with the science and with the scientists can change them and have such a positive influence on their outlook.
What we first did was the laser hair diffraction experiment. We shone a laser onto a single strand of hair, and we can use this to determine the width of a single strand of hair.
We learned that diffraction is the bending of light by objects they can pass through, and depending on the wavelength of light, it will bend to a different degree.
Her hair was 71.35 micrometers, which is much thicker than mine.
The kids were able to move very quickly into the elaborate and the understanding sort of area, and they were able to see things and engage with things and put their hands on things that they might have only seen from a computer screen. By having that experience, all of them were so engaged and they knew exactly what they were talking about in their presentations, and then they were able to really clearly articulate what they've learned.
The second experiment or activity we did was the AFM machine. An atomic force microscope, it's a special type of microscope and it's used to generate images of surfaces at a microscopic level. So it's used to measure things such as height or the depth of the surface, friction, magnetism.
The cool thing about atomic force microscopy, or AFM, is that it's very different to things like electron microscopy or optical microscopy, where instead of using something to see, so either some type of light or electrons, we actually feel what the sample looks like. So it's kind of like a blind person with their walking stick or their cane that taps around.
There's a probe, which is very small, and it's attached to a cantilever. And this cantilever either slides across the surface or it bounces on or just above. And as it moves, the point of deflection of the laser beam, which shines on the top, changes and hits different places on the detector.
So the height retrace is it scans the surface to determine the different heights of the surface of the hair, and we're able to determine the width of the hair from the red and blue lines. The hair seemed to be thicker through the microscopy, but we think it's because we use different areas of the hair, because the root of the hair is much thicker.
Yeah.
So maybe that's why the results varied.
So yeah, when we shine the laser onto our hair, we might have actually measured a different section of that hair, and then when we did the AFM, we could have probably measured a tiny bit further or closer to the hair, and that depends. That's why we have varied results for our width of our hair.
This program really opened my eyes as to where I can end up. I might not necessarily want to become a physicist, but I want it to be a part of what I do.
That's probably what I've really enjoyed most out of the program, is seeing these kids develop. How on the first day they were like, I don't know what science is, I don't really like science too much, to I can see myself in a career in science. And that happened in 2.5 days just through these experiences. So I think this is a really positive program and has a lot of potential.